Hi, and welcome to 6.2 Solving Linear Systems by Addition. So just a little bit of review from 6.1. What is solving a linear system? So a reminder, a linear system is just two or more linear equations. Two or more, we only deal with two, linear equations. And the solution, that's not how I spell equations, the solution is the single point that will satisfy both of those equations. So if we were to do a little sketch, in 6.1 we graphed them, so I could have one line like that, and I could have another line like this, and the point where those cross is the point that solves both of those lines. That point exists on both of those lines, and therefore it is the solution to that linear system of those two lines. So in 6.2, we're going to do solving linear systems by addition. The textbook writes this down as sort of a brand new law. And what they do is they write it down as if A is equal to B and C is equal to D, then A plus C is equal to B plus D. If that makes sense to you and you want to memorize it, that's completely fine. But I'm not usually a fan of just memorizing things when we do math. I want to understand why they work that way. And since I've got a pretty poor memory, I actually don't want to have to memorize anything new at all. So the way I think about this is there's really only two laws to algebra. Law number one is BEDMAS, which is order of operations. You always have to follow your order of operations. And law number two is what you do to one side, you must do to the other side. And that just means that your equation stays balanced the whole time. If you did one thing to one side and something different to the other side, it would no longer be the same equation. But as long as you do the same thing to both sides, it's still the same equation. It's just a different way of writing the same equation. So if we look at this, I'm going to write something similar down to what the textbook writes, but I'm going to color code it a little bit. I'm going to write A is equal to B. And maybe I'll do this in two steps. And then I've got this C is equal to D bit. C is equal to D, which is just normally black. I could add A to both sides. Plus A, plus A. That's a completely legit thing to do, and it looks really normal. We added the same thing to both sides. But now if I look on my right-hand side, if I want, A is the same as B. So this would be exactly the same as writing A plus C, and I'm going to see if I can be consistent with my colors. A plus C is equal to D plus B. And that is okay because A is the same thing as B, as we've written over here. And so I've essentially done that. What I do to one side, I have to do to the other. I've added the same thing to both sides. I've just written them differently. So what we're going to do next is we're going to look at why this might be useful. These examples are simplified a little bit. We're going to get into some tougher ones for sure, but they are a great warm-up and demonstration of why we would do this. And we're also going to, in the next step, set up a little bit of a system so that for those of you that like systems, this might be easier to reproduce. So what I'm going to do is I'm going to color code this again. I'm going to write y is equal to, and then this negative x in green, just so we can see that the red is equal to the green. So I have the first equation, y is equal to x plus 8, and I am going to add the second expression to it. So on my left-hand side, I'm going to add y, and on my right-hand side, I'm going to add a negative x. So what I can do next is I can simplify. I'm going to combine my like terms. Y plus y is 2y. And then on the outside of my right-hand side, what I've got is this negative x, and I've got a positive x. A negative x plus a positive x is 0. Then all I've got left on my right-hand side is 8. So I end up with 2y is equal to 8. I can divide both sides by 2, and I end up with y is equal to 4. Notice how I now have half of the solution. If I scroll back up here, my point is going to be an x-coordinate and a y-coordinate. I have found my y-coordinate. If I want to, I can substitute this back in, and it turns out I do want to do that. So I'm going to take 4 and substitute it in for y. 4 is equal to negative x. To get x all by itself, all I have to do is multiply both sides by negative 1. So x is equal to negative 4. And my complete solution to this linear system is then negative 4, comma 4, put it in brackets, and that is a point. So that is now the solution to my linear system, and I didn't have to graph anything. This works really nicely, especially if you don't have a nice point. This one is a nice point, negative 4, 4, but sometimes they're not. If we take a look, what I've done is I have, in fact, graphed these. This red line is the x minus 8, and the blue line is the negative x, and if I tap that point, the solution is negative 4, 4. So if you want, you can use Desmos to double check these. Graph the two lines and see if the intersection point is the answer that you got. However, you will need to be able to do this algebraically as well. I'm going to do one more example that's quite similar. A minus b is equal to 3, and b is equal to 2a. I'm going to try and do my color coding again, and I'm just going to write the exact same thing underneath it. B is equal to 2a. So I have this first expression, a minus b is equal to 3. And on the left-hand side, I'm going to add b. And on my right-hand side, I'm going to add 2a. What I did to one side, I did the exact same thing to the other side, even though it looks a little bit different. I'm going to combine my like terms. I've got a positive b and a negative b, so they cancel. On my left-hand side, I've only got a. On my right-hand side, I've got a 3 plus 2a. Those can't be combined because one has an a and one doesn't. So now I need to try and isolate a. Notice how I have a in two spots. I have an a on the left-hand side, and I've got two a's on the right-hand side. I want to try and bring them together and get them on one side together. So I'm going to subtract 2a from both sides. On my right-hand side, a positive 2a and a negative 2a is 0. A minus 2a is a negative a. That's going to be equal to 3. Multiply both sides by negative 1 to get a positive a is equal to negative 3. Again, now I have half of my complete solution. I can take this and I can substitute it back into my bottom equation. I could do it into either equation, but the bottom one for me right now, because I've practiced these a bunch, looks easier. A b is equal to 2 times negative 3. B is equal to negative 6. So now I have this ordered pair solution again. I've got a negative 3, negative 6. And that would be the solution to this linear system. So let's take a look at a few examples that are going to be a bit more like the ones that you guys are going to do. So this is a little bit harder, but it is the same idea. So this is my free-flowing way, which is what I've been doing, and then I'm going to show you the textbook structure and how they've done it. And then I think I want to do a double check, so I'm going to remind myself to do that here, a double check. And then we're going to go back up and start that question. 2x plus y is equal to 6. 4x minus y is equal to 12. So I'm going to do this part in red and this part in green. And my free-flowing way is I'm going to start with my 2x plus y is equal to 6. Now on my right-hand side, I'm going to add this 12, which I said I would do in green, so I'm going to do in green. And then on the left-hand side, I would do this plus 4x minus y. I added this whole thing. I'm just putting the brackets there so you can see how it's been added. But since I'm just adding everything, they don't contribute anything, so I'm going to take those brackets back out. So now I'm going to simplify. I'm going to combine my like terms. I have a 4x and a 2x. 4x plus 2x is 6x. And I have a negative y and a positive y. This is very convenient. A negative y and a positive y added together is 0, so I don't have to write anything down. And on the right-hand side, 6 plus 12 is 18. I can then divide both sides by 6, and I end up with x equal to 3. And I have half of my solution to my linear system again. I can then take this x equal to 3 and plug it into either one of those. Notice how now, if you were paying attention to the last one, there was an easy option. Now there's not really an easy option. They are both exactly the same. So what I'm going to do, just because I chose the bottom one twice before, is now I'm just going to choose the top one. So it's a 2. Maybe I'll do the whole thing. I'm going to show a bit more work. 2x plus y is equal to 6. I'm going to take this 3. I'm going to put it in to the x, and I end up with a 2 times 3 plus y is equal to 6. I can simplify, so I'm going to simplify. I get a 6 plus y is equal to 6. And now I want to isolate y. I'm going to subtract 6 from both sides. Subtract 6. And 6 minus 6 is 0. So now I have my solution to this linear system, which is x is equal to 3, y is equal to 0. And that would be my final answer. Again, the textbook sets you up with a little bit of a system. I like the system because it's easy to follow and it gives you nice, neat steps, but I don't like the system because it gets away from the idea of what you do to one side, you do to the other side. That being said, I think it is a little bit simpler, so it's going to be the way that I'm going to try and do just about all the rest of the examples. So the textbook structure tells you to set these up, my 2x plus y, in nice, neat little columns. This one already is, and this is going to look exactly like the question to start with, minus y is equal to 6. And what I want to do is I want to put the x's in a column, my y's are in a column, and I've made a typo here already. This is a 12, and I want my constants in a column. And then what I'm going to do is I'm going to do some addition. My 2x plus 4x is 6x. My y plus a negative y is 0. And that's equal to 6 plus 12, which is 18. I can then simplify this. I don't need to write the 0 anymore. I get to this 6x is equal to 18 place right away. And it's just a little bit neater to get there. I'm going to divide both sides by 6, just like I did up top, and I get an x is equal to 18 divided by 6, I believe, is a 3. And then I'm going to have to do the exact same thing. I'm going to take this 3 and I'm going to substitute it back in to this equation. So I have my 2 times 3 plus y is equal to 6. My 6 plus y is equal to 6. So y is equal to 0. Notice how much work is required to write down these questions. You cannot skip it. There's no way to skip it. You can't do these in your head. The first two I showed you, maybe you could have done those in your head. These ones, substantially more difficult. You're going to have to show the work for all of them. The more you practice showing your work, the easier it will be. Notice how first one is the same as the second one. I did it 2 different ways. If I do it 2 different ways and I get the same answer, chances are really high that I'm right. But if you want to do a double check and you don't want to do the complete questions twice, there is a way to do this. So notice how in both of them I took this 3 and I plugged it into the top equation. To double check, take the point, take the solution, which is the point, and substitute it back into the unused equation. So while I did use both of them initially, this bottom one, this 4x minus y is equal to 12, I haven't really substituted anything into, so that's my double check solution. If I put my x into the first equation to get my solution, I want to double check using my second equation, and vice versa. If I'd substituted my x into the bottom equation, I'd want to use the top equation to double check. So what I'm going to do is I'm going to take this whole number and I'm going to do my double check. And when I do my double check, I want to see if my left-hand side equals my right-hand side. So I'm just going to make a little t-chart here. I'm going to get rid of that equal sign. I'm going to make a little t-chart. On my left-hand side, I'm going to substitute those variables in. I've got a 4 times 3 minus 0. And on the right-hand side, I'm just going to have 12. There's no variables over there, so that's really nice. And I end up with a 12 is equal to 12. Yes, is a solution. Let's take a look at a couple more examples. So one more layer. These are kind of the level that we're trying to get to. So I have this 2x plus 3y is equal to 2, and an x plus y is equal to negative 9. And so I'm going to pretend that I haven't noticed that anything's different, and I'm just going to try and solve it the way I would before. And the textbook says I arrange these in nice, neat columns, is equal to 2. And so my x I want to write first, plus y is equal to negative 9. These are both in standard form, so my x term comes first. Then my y term is equal to my constant, but that won't necessarily always be the case. I'm going to set this up. I'm going to add them together, and I get a 3x minus 2y is equal to negative 7. You will notice that I didn't manage to get rid of one of my variables. This third equation that I have, this 3x minus 2y is equal to negative 7, I can't solve for any variable. This cannot be solved. So I'm stuck. That wasn't actually helpful. So my trick kind of backfired on me a little bit. But with a little bit of critical thought, what we can do is we can still make this work for us. And if you've used the memorize the new law trick, and we're just kind of memorizing this, then it's a little bit harder. But if remember what we do to one side, we have to do to the other side, then we can use that again. So our goal here is to get rid of one of the variables so that we can solve for the other one. So we're going to arbitrarily choose which one to get rid of. Notice how I've written down here critical thought leads to two options. It doesn't matter which option you choose. Both are equally good. I'm going to do them both ways. So let's try and get rid of the x. Get rid of x. So I'm just going to write down my first equation. My 2x minus 3y is equal to 2. Eventually, you guys should get good enough at this that you can kind of predict what's going to happen, and you can predict which equation you're going to have to manipulate, or both of them. But I know just from looking at it right now that I don't need to manipulate my top one. And then my bottom one, I've got an x plus y is equal to negative 9. So I want to get rid of the x. So what can I multiply this bottom equation by so that when I add them together, my x term goes away? So on my top, I have a positive 2x. So in order to make a positive 2x go away, I'd have to add a negative 2x. So what I can do is I can divide this whole bottom equation by negative 2. The whole thing, which means that every single term in it is going to get multiplied by negative 2. I'm going to have to multiply it by the x, I'm going to have to multiply it by the y, and I'm going to have to multiply it by the negative 9. So what I end up with is this negative 2x plus y, I made my very fatal mistake there as well, minus 2y is equal to a positive 18. And then I'm going to write this, if this is equation 1 and this is equation 2, I'm going to write this first equation down again. I've got this 2x minus 3y is equal to 2. And I'm going to add these equations together. My negative 2x plus positive 2x, 0, which is exactly why we multiplied it by negative 1. That was the whole point. My negative 2y minus 3y is a negative 5y, and that's going to be equal to 18 plus 2 is 20, and I end up with y is equal to, dividing both sides by negative 5, divide that side by negative 5, and then I'm super crowded, so I'm going to move down. My y is equal to a negative 4. I'm not quite done yet. I've only got half of my solution. It's a good idea when I substitute it back in not to use my manipulated equation, but to choose one of the original ones. So I'm going to substitute back into equation number 1. So I end up with a 2x minus 3. I'm going to substitute that y in. Negative 4 is equal to 2, and that's from equation number 1. I'm going to simplify first. 2x at negative 3 times negative 4 is a positive 12. That's equal to 2. I'm going to subtract 12 from both sides. My 2x is equal to a negative 10. Divide both sides by 2 gives me that x is equal to negative 5. So my final solution is negative 5, comma, negative 4. Instead of redoing the double check here, what I'm going to do, is because I've run out of space, is I'm going to go back up and I'm going to lead you through the second option, and if they're both the same, then I'm pretty sure we got the right answer. So now I want to try, and you wouldn't necessarily have to do this, it would be much faster just to do the double check. Get rid, I just realized that I'm spelling ride instead of rid. Get rid of y. This is an equally valid thing to do. My first equation again is 2x minus 3y is equal to 2, and this little 1 is helpful for me to talk about things, but you don't need to write it. And my second equation is x plus y is equal to negative 9. So I'm going to look at this second equation again, equation number 2, and try and think about what I can multiply the whole thing by to get rid of my y term. In equation number 1, I have a negative 3y. So to get rid of a negative 3y, what would I have to do? I have to add 3y. So I would want a positive y. So I'm going to multiply this whole equation by 3. Every single term must be multiplied by 3. So I get this 3x plus 3y is equal to negative 9, 18, 27. I said 27, I wrote 29. Let's write down 27, and then I'm going to write down equation 1, and I've just flopped the order of them. It doesn't actually matter, because it doesn't matter what order we add things in, so it doesn't matter what order we write these things down. My equation number 1, 2x minus 3y is equal to 2, and I am going to add these things together. 3x plus 2x is 5x's, negative 3y, positive 3y, is 0, which again is the whole point. And I have this negative 27 and a positive 2. If I add that together, I think I get a negative 25, which means if I simplify this, I've got a 5x equal to negative 25. I can divide both sides by 5, and I end up with x is equal to negative 5. Notice how that's what I got on the left-hand side, so things are looking pretty good, but I'm going to keep going as though this was an independent solution. I'm going to take this negative 5, and I'm going to substitute it in to my 2x minus 3y is equal to 2. So I have a 2. My x is going to be negative 5 minus 3y, and this is just from equation 1, is equal to 2. I'm going to simplify. I get a negative 10 minus 3y is equal to 2. I can add 10 to both sides, and I get a negative 3y is equal to 12. I divide both sides by negative 3, and I end up with y is equal to negative 4. I end up with the exact same equation, or the exact same point as I did on the left-hand side. Two different ways of doing the exact same thing, both of which are equally correct. With critical thought comes a little bit more options for solving things different ways. So negative 5, negative 4, final answer. Let's keep going. 6.2D. You thought lowest common multiple was silly. So let's look at this one. So if you follow the last one, and the last one makes sense, I want to try and get rid of one of my variables. So I've got a 4x plus 3y is equal to 5, and a 3x minus 2y is equal to 8. And so in order to get rid of my x, is there anything I can multiply the bottom one? If I've got a 4x, what can I multiply the bottom one to make it 4? And it looks like it would be a nasty fraction, and I don't want to have to do that. Okay, well, let's try and get rid of y then. What do I need to multiply negative 2 by to get negative 3 so that my y terms would go away? Oh, I'd have to do a fraction again. And so instead, but I'm going to end up doing these both ways for fun, apparently. Oh, and I give myself lots of space, which is exciting. Instead, I'm going to have to multiply both the top by something and the bottom by something. So let's look at the lowest common multiples of 4 and 3. So 4, 8, 12, 16, and 3, 6, 9, 12. Oh, there it is. There's my lowest common multiple for 3 and 4. It would be 12. So what would I have to multiply my top equation by? And maybe I'll just write these down because I'm going to do them both ways. I've got my 4x plus 3y is equal to 5, and my 3x minus 2y is equal to 8. So what do I have to multiply 4 by to get 12? I have to multiply my top one by 3. And then what do I have to multiply my bottom equation by to get 12? Well, I'm going to have to multiply it by 4. And now when I add them together, I want my x term to go away, so I'm going to multiply it by a negative 4 so that my bottom one ends up with negative 12. I'm going to have to, again, multiply my 3 into all 3 terms. I get a, and I'll just number these again because it's nice to be able to talk about them with numbers. I end up with a 12x plus 9y is equal to 15. And I get a negative 12x plus 8y, since a negative times a negative is a positive, is equal to 8, and 8 is 16, which is a 32, and I think that's a negative 32, except I'm going to lose that negative sign. It's kind of lost in my equal symbol. There we go. Cool. And now I'm just going to add them together. 12x minus, or plus a negative 12x is 0. The whole point. It's why we did all this. A 9 plus an 8 is a 17. And a 32, a negative 32 plus 15. And now I'm going to have to get my calculator out because this is a little bit tricky. 15 plus negative 32 is going to be, oh, this is so convenient, a negative 17. I thought it might be something nice. So to simplify, get a 17y is equal to negative 17. Divide both sides by 17. And y is equal to negative 1. I'm then going to take that. I'm going to substitute it into equation 1 again. And from equation 1, I get before I've multiplied it by anything, I get a 4x plus 3 times negative 1 is equal to 5. My 4x minus 3 is equal to 5. 4x, a negative 3, I'm going to have to add 3 to both sides. 5, 6, 7, 8. I get, divide both sides by 4. I get an x is equal to 2. So then I have the point 2, negative 1. Final solution. That would be done for us. We could then take that and we could double check if we want. I highly recommend you double check. As we're noticing, this is a page worth of algebra. Chances are reasonable that people are going to make mistakes, especially at the start. So go back and do the double check. Substituting that value in also gives you more practice to do algebra. Don't just look at the back of the book. Do the double check. If you want a faster double check, practice graphing them. Take both of those and graph them. You could either graph them by hand or at least plug them into Desmos. Practice using all of these skills you've learned so that you can get to the right answer multiple ways and be satisfied before looking at the back of the book that what you're doing is actually correct. Okay, so that was getting rid of x. I'm going to go back and that would be done. We would be done. But I just want to show you the other way as well, where you could have chosen to get rid of the y term. I have my 4x plus 3y is equal to 5, and 3x minus 2y is equal to 5. And now I'm going to have to look at my lowest common multiples of 3 and 2 if I want to get rid of my y. So my common multiples of 3 are 3, 6, 9, 12, and my multiples of 2 are 2, 4, 6. Oh, there's my 6's. Okay, so I want to make 6's. One of them's got to be positive, one of them's got to be negative, so when I add them together, they go away. I've already got a positive and a negative, so I don't need to really think about that too hard. They'll just end up going away. The top one, in order to make my 3 a 6, I'm going to have to multiply it by 2. So I end up with an 8x plus 6y is equal to 10. And my bottom equation, and that was equation 1, and this one will be equation 2. My bottom equation, in order to make my negative 2 a 6, I'm going to have to multiply it by 3. So I end up with a 9x minus 6y is equal to 15. And that's equation 2 once I've multiplied the whole thing by 3. And then I'm going to add them together. 8 plus 9 is 17x plus 0 is equal to 25, and that means I suspect, since I'm going to get a different x value, that I think I've made a mistake. Okay, and I did find my mistake. Oh, I'm so sorry, guys. And it's way back up here. So this term right here, I wrote a 5 mistakenly. It should be, of course, an 8. So this number should be an 8 there, which means when I multiply 3 by 8, I get, what do I get? I think I get a 3, 6, 9, 12, 12 is 24. So I get a 34 when I add those together. My 17x is then equal to 34. And if I divide both sides by 17, my tablet's struggling for a second, I get left with my x is equal to 2. So the reason I knew I'd made a mistake is because I was getting something different on my left-hand side than my right-hand side, and I was really worried it'd be in my red solution and I'd have to go all the way back to the beginning. But since my solutions were different, I was able to find my mistake. I've also written my work out really nicely so that when I go back and read them, I'm like, oh, there's my mistake. I'm going to go back. I'm going to substitute my x equal to 2 into equation number 1. So I get a 4 times 2 is equal to, plus 3y is equal to 5. I'm going to simplify. 8 plus 3y is equal to 5. I'm going to subtract 8 from both sides, and I end up with a 3y is equal to negative 3, so a y is equal to negative 1. So my solution, left-hand side, it works out exactly the same as my right-hand side. Red is the same as green. I end up with a 2, negative 1. Two different ways doing the exact same thing. You would only ever need to do one of those ways. Let's look at 6.2. I've got 2 more here. I'm only going to do these one way. I'm not going to get rid of both the variables this time. What I'm going to do, so it's just going to look a little bit more like a normal question. So when I'm looking at these, I noticed that it'll be pretty easy to turn this 3. I can multiply the top equation by 2 to get 6, or I could multiply it by 2 to get 4. I don't really mind, so I'm going to choose, just because the x is first, let's get rid of the x. I'm going to multiply this top equation by 2, and I end up with 6x minus 4y is equal to 2. And then on the bottom, I have a negative 6x plus 4y is equal to 10. When I add my x terms together, let's just add them together. When I add my x terms together, I get a 0. Oh, also when I add my y terms together, I get a 0. And on my right-hand side, I get a 12, which is super strange. So I'm like, oh, what is happening? So if I'm stuck, and this isn't a question from the textbook, I'm now, well, what do I do if I can't look up the question in the textbook? And I can do the exact same thing that I've been telling you guys to do, is I can open up Desmos, and I can just make this so that you guys can see it, and I can see it, and I can type them in and be like, wow, I wonder what's happening. Let's type in this 3x minus 2y is equal to 1. And I've got this minus 6x plus 4y is equal to 10. Oh, I don't know what that negative sign's doing there. And I can look, oh. So what I've actually got is I've got 2 parallel lines that never, as far as we can look as far as we want left. We could look as far as we want right. At no point in time do they cross. They do not share any points, which means there is no solution. Because the left-hand side can't equal the right-hand side. 0 does not equal 12. There is no solution. So let's look at the next one. These are a little bit rare, these two, but they do come up and they're worth knowing about. So this next one, I got a 2x plus 5y is equal to 2, a negative 4x minus 10y is equal to negative 4. Again, I'm going to look at these. I noticed that I could do something to my 2 to get to 4 pretty easily, could do something to my 5 to get to my 10 pretty easily. So let's take this whole thing and let's multiply this top one to make the 2 into a 4. I'm going to multiply it into 2. I'll end up with a positive 4 and a negative 4, and they'll go away. So I end up with my 4x plus 10y is equal to 4. And I end up with and I don't do anything to my bottom one because it's going to work. add them together. My 4x is a 0, and I'm like, oh no, I'm getting the same thing again. My y terms are also a 0, but this time the right-hand side is the same as my left-hand side. 0 is equal to 0, which means it doesn't matter what variables I put in here. The left-hand side is always going to be equal to the right-hand side, which is weird. So let's take a look at this one too. So I'm going to go back into Desmos, rearrange some things a little bit. I'm going to get rid of those last two equations, and we're going to type in some new ones. I've got my 2x plus 5y is equal to 2, and I've got my minus 4x. And notice how I'm typing the original ones in. I'm not typing with the ones that I've mucked with, because I'm still thinking maybe I made a mistake, equals negative 4. And I'm off a little bit here, and I'm looking around at Desmos. I'm playing with my axes a bit, and I'm looking for my blue line, and I can't find it. Maybe try switching it off and on, and I don't really see it come up. Oh, there it is. It's there. It's over top of my black one. So notice how my black and my purple lines, there's my purple line, there's my black line, are in the exact same spots. They're overlapping each other. So this one, there is an infinite number of solutions. Infinite number of solutions. So if the left-hand side equals the right-hand side and there's no variable, then infinite number of solutions. But if the left-hand side doesn't equal the right-hand side and there's no variable, there are no solutions. Okay, we're on to the last page. I know this is a very long one. Let's look at this one. Y is equal to x plus 4, or x plus 2y is equal to 5. So, do you go with the flow, or do you like the structure? So I'm going to do this both ways. I'm going to rewrite my top equation with some colors. I've got a y is equal to x plus 4. Actually, I think I like this a bit better if I just circle them with colors. I've got my y and my x. Yeah, that looks way better. X plus 4. So on my I'm going to also have to think about this critically. This one's a bit harder than I thought it was going to be. I've got to make a variable go away. I'm going to make the y go away. And so I've got positive 2y here. I'm going to need to make this a negative 2y to make it go away. So I'm going to multiply this whole thing by negative 2, which means I end up with a negative 2y minus 2, is equal to minus 2x minus 8, and then I'm going to color code this one for us. I'm going to take this equation, I'm going to add it. I'm going to take equation 1 and add it to equation 2. So I end up with my negative 2y plus x plus 2y is equal to 5 plus negative 2x minus 8. So on my left-hand side, I've got this positive 2y and this negative 2y, which is exactly why I multiplied it by negative 2. It's the whole point of the exercise. And I end up with x is equal to, I've got a positive 5 and a negative 8, which means I've got a negative 3, and then on my right, and then I've also got this negative 2x. I end up with x in two different places, so now I just have to move them over to the same size. I'm going to add 2x to both sides. I end up with a 3x is equal to negative 3, so x is equal to negative 1. And then I can substitute this back into my top equation. I end up with a y is equal to x, which is negative 1, plus 4. Y is equal to 3. And I have my solution. Negative 1, 3. So that was going with the flow. All I did was I went, oh, this one isn't quite set up the way the rest of them are, so I'm just going to add the left-hand side to the left-hand side, the right-hand side to the right-hand side, and it also took some critical thought. I think in this one, that's the faster way to go, but it does require a greater understanding. If you don't like that, we can show you how to develop that structure. I'm going to do this one maybe in blue. I'm going to start over here just so I have more space, because I think this is going to take some space. Structure. I have my y is equal to x plus 4, and my x plus 2y is equal to 5. All of the other ones we've done so far have been in standard form. My bottom equation, which I've called equation number 2, is already in standard form. So in order to follow the structure, follow this same set of rules that we've been following the whole time, they're not really rules, they're just a method. To follow the same method we've been following the same time, we want to take equation number 1 and we want to put it into standard form as well. In this particular case, it's pretty easy to do. There's really only one step. I'm going to subtract x from both sides, and I end up with, for equation 1, I end up with this y minus x is equal to my positive, my negative cancel, 4, and then for equation 2, I've got this x plus 2y is equal to 5. My x's and my y's don't line up, so I'm just going to reorder them. Equation 1 in proper standard form, just about my x term is first. It's not positive in this case, but since we want to get rid of them, we want to get rid of those x terms, we're going to leave it as negative. So it's almost proper standard form. X plus 2y is equal to 5. And so this is now all I've done is I've changed them both into standard form, and then I've made these nice little columns where my x terms line up, my y terms line up, and my constants line up. That's all I've done. I noticed right away that after rearranging them, I actually don't have to multiply it by anything. I've got a negative x plus a positive x is a 0, and that is a not an equal sign. And then my y plus 2y is a positive 3y, and my 4 plus 5 is a 9, which means my y would be equal to 3. I would then take this 3, I would plug it back into one of the original equations. I end up with a 3 is equal to x plus 4. I'm going to subtract 4 from both sides. Negative 1 is equal to x. And I end up with this exact same point. Negative 1, 3. So just to show that the way we went about it to start with is occasionally easier if you remember your basic rules, what you do to one side, you do to the other side, and follow bed mass. And also just looking at our right-hand side, or sorry, this blue solution. If you want to set up that structure, if the structure really makes sense to you, I think that was a little bit longer in this particular instance, but you can still follow that method for every single one. I've also decided to add a bonus question for all those of you who made it to the last little bit of this movie, and I'm going to put the bonus mark into your quiz. And just answer green. The bonus question is going to say, what's the answer to the bonus question? And you just have to type in green, and then you're good to go.
Thank you for watching, and I just wanted to remind you guys a couple of keys for success. Number one, you got to do the practice questions. If the things I'm saying make sense, that's phenomenal, but you still have to practice and make some mistakes on your own. And that goes along with number two. If you get stuck, ask me questions, get in touch, write me an email, make an appointment, or leave a comment on the YouTube video. And step number 3 to success is look after yourself. Eat good food, get some exercise every day, and socialize as much as you can right now. I hope you guys are all doing well, and I will talk to you soon.